Hi there, so in this video you should have already seen how to find the circumference of a full circle using the formula C equals pi d. What we're going to do now is we're going to look at parts of a circle and we're going to focus on quarter, half and 3/4 circles, okay, ones that are identifiable as those fractions. In National 5 you'll be shown random size parts of circles, but right now we're focusing on the halves, the quarters and the 3/4. So here is a circle, and what I've got is I have shaded a quarter of the circle pink. Now normally, I'll be honest, there should be maybe a little right angle in there. We shouldn't be having to assume that it's right angled. So that bit that's in red or pink there is a quarter of a circle. Now the name for this is called a sector. So this little bit here is called a sector. And this big bit here is called sector as well. And this line that's coloured in red is part of the circumference of a circle. Now your part circumference, rather than keeping saying part circumference, they start to call that an arc. So that shape there it makes is an arc. And you might have heard of the word arch before, and an arch you'll recognise as part of a circle. So arc is what we now call circumference for part of a circle. So today you're really finding the length of an arc, okay? So before we start, I just want to remind you of these common decimals, and you should know these. You should know that a quarter is 25%, 0.25 is a decimal. A half is 0.5 and 3/4 is 0.75. That's going to help us today with our calculations, because instead of writing typing in a quarter, we'll type in 0.25. Instead of typing in a half, we'll use them as decimal forms instead, because they're just easier to type in. So that's worth copying down. So here are my two examples. I want to find the arc length. So the first one in blue is identifiable. It's a half circle, isn't it? So your circumference is normally pi d, but because it's a half circle, I'm going to make you change that to a half pi d. All right. Now, a half I'm going to change to a decimal is 0.5. We use 3.14 as pi, and our diameter is the full width of the circle, so the diameter is 11. And then you'll type that into your calculator, and you'll get 17.27. Now that's the two decimal places, so I'm probably just going to keep it to two decimal places. So that is the length of that arc there, this length here, okay? It is half of the original one, so that's why we put the half at the front. Personally, you could also use, instead of typing in 0.5, if you're comfortable, you could use your fraction button and put in a half. Other options is you could just do 3.14 times 11 and then divide by 2 at the end. That's all the same things, as long as we're halving somewhere, that would work. But this is the preferred method I'm going to do. For my yellow one here, you can obviously see that that is a quarter of a circle. So we change our formula now to a quarter pi d, okay? So a quarter pi d. Again, alternatively, you could just divide by 4 at the end, but I'm trying to lead you into what you'll be doing at National 5. So we write a quarter as 0.25 times 3.14 times, now be careful, if this was a full circle drawn out, the diameter would actually be 12 plus 12. So diameter here we're using is 24. And if you type that in your calculator, you get 18.84 centimetres. And that's, again, to two decimal places already. And I'm going to leave it as that. Question 3, this is a wee bit trickier. We have, it looks like a Pac-Man, doesn't it? This is a 3/4 of a circle. So that wee bit that's been cut out is a quarter. So we are going to change our formula this time to 3/4 pi d. So circumference equals 3/4 pi d. And 3/4, you can either use a fraction button or you change that to 0.75 times 3.14 times, now remember that 11 is only your radius, so that bit there is 11. This bit here would also be 11, so your diameter is 22. Type that into your calculator, and you get 51.81 centimetres. So that is the distance right the way from there to there, is 58.81 centimetres. The reason I like doing it as a decimals is it's much easier than then having to use your fraction button that you might not be comfortable with, or remembering to do a divide at the end of the sum. So let's have a look at some more complicated examples. So they can change the questions here and they can ask you not for the arc length but total perimeter. So please remember, total perimeter of a shape is if you are walking right around it. So for this shape here, we're going to, if this was my starting point, I would walk right the way around the arc, and then I would walk along the 3 and then back the way along another 3. So the total perimeter for this one is going to be your arc plus 3 plus 3, the total distance around about it. So our arc will be, it's a quarter circle, so we'll do a quarter times pi d. So we'll do 0.25 times 3.14 times, now remember that 3 is only your radius, your diameter would be 3 plus 3, which is 6. So if you work that out, you get 4.71. So remember, that is just this arc bit, that is just my black line, that's just the arc. So the total perimeter, I'm going to use P for perimeter, is 4.71 plus 3, which equals 10.71 centimetres. Okay, so the minute you see perimeter, you need to do the total from start to finish. Similarly, in this one, we've got a half circle. So I'm going to go do C equals a half pi d. So I've got 0.5 times 3.14. Now, 13 is the base of the rectangle, so 13 is also the top of the rectangle, which is my diameter. So we're doing 0.5 times 3.14 times 13 into our calculator, and that gives us 20.41. So our total perimeter is our arc of 20.41. And then I'm just going to trace around with my pen. So that is your 20.41. We then need to add on 7. We then need to add on 13. And then we need to add on that length again there, which is another 7. So you need to add on all the outside bits of that rectangle. So if you add on those, you get 47.41. So this is more an exam or a test style question. It's much more difficult than just asking you for the arc. And I've got one more wee example to show you. So this one looks a bit like a running track type shape. Now what you've actually got is you've got a half circle at one end, a half circle at the other, and then a rectangle in the middle. So what do you get when you've got a half circle plus a half circle? It makes a full circle, doesn't it? So rather than find a half circle and then double it, we're just going to find a full circle. So for the circumference part, will just be normal pi d because it's a full circle. So we'll have 3.14 times, now diameter is there is 25. So we'll do that on our calculator, which gives us 78.5. Now the total perimeter would have been my arc, and then I've got a 30 at the bottom and a 30 at the top. So it's 78.5 plus 30 plus 30. And that gives you 138.5 metres. Oh, sorry, centimetres, what am I typing? For the full perimeter. So remember, 2 half circles make a whole circle. There's no point in finding half a circle and then doubling it. You're giving yourself extra work, okay? So as always, here are some questions. Now I've got my questions in 2 parts. These are my straightforward ones, where it's just half, quarter and a 3/4 circles. Nice and straightforward, plugging into your formula. Pause the video and give these a try. Unpause it and check your answers. So there's your answers to those 6 questions, okay? Now I've got some more difficult ones. These ones you'll notice ask for total perimeter of the shape. So for question 7, you'll do a half pi d and then you'll add on the 14. For question 8, you'll do a quarter pi d, add on the 6 and the 6. And then they become a bit more like the examples I have done that are a wee bit harder. So pause, give them a try, and then unpause and your answer should come up. And then that's your answers to those harder questions. So hopefully you've got on okay with these. Thank you very much for watching. Bye-bye.